In this video, I'll talk about the product rule in differentiation and how you can use the product rule to differentiate functions of the type shown in these two questions. First, I'll explain when not to use the product rule. Do not use the product rule if you are given a question such as this. Now, if given such a question, this can be expanded out quite easily. After that, you can differentiate it in the normal way. I'll show how this can be done without applying the product rule. Expanding out this bracket, we'll get x squared plus 6x plus 9. Further expanding out, we'll have x cubed plus 6x squared plus 9x. And differentiating, we'll have dy dx equal to 3x squared plus 12x plus 9. So you can see this can be done quite easily without the product rule. So we apply the product rule if we have a function with a power of 3 or higher and another function multiplied to it, or when we have a square root as shown here. This is the formula for the product rule, differentiating u and v with respect to x. U and v represent the two functions here. This is our u and this is the v. So when you differentiate u and v, first leave the u alone, that is, leave the first function alone, and differentiate the second function, plus, and then leave the second function alone, differentiate the first function. So now I show you how you can do this question. Let's start with the first one. We are asked to differentiate each of the following with respect to x. We can write this as d dx followed by the two functions Now applying the formula, first leave the first function alone, just copy it down. Now differentiate the second function using the chain rule. What this means is, first bring down the 3 to the front of the bracket, write down the bracket, reduce the power by 1, and differentiate within the bracket. Differentiating 3x minus 1 will give us 3. The negative 1 disappear. And multiply this to the rest of the answer here. And plus, following the formula here, now leave the second function alone. Just copy it down. 3x minus 1 cubed. Now differentiate the second function. Since the power outside this bracket is 1, no number shown here means it is 1. We do not have to apply the chain rule as we have done here. Just differentiate within the bracket straight away. When you differentiate x squared plus 1, what you get is 2x. The plus 1 disappear upon differentiation. Now let's simplify this expression first. 3 multiplied by 3 will give us 9. We can write this in front here and write down this bracket, x squared plus 1, and this bracket 3x minus 1 plus. Now the 2x can be written in front here, followed by this bracket 3x minus 1 cubed. Now this can be factorized. We can bring down this bracket and one of this bracket outside. So we have 3x minus 1. When we bring out this bracket, we are left 9 and the bracket here. And plus 2x and the square of this bracket. Okay, let's simplify within the square bracket here. We have 9 x squared plus 9 plus 2x. Now let's expand out this bracket here. We'll have 9x squared minus 6x plus 1. Further simplifying, we'll get 3x minus 1, 9x squared plus 9 plus 2x multiplied by 9x squared will give us 18x cubed. 2x multiplied by minus 6x will give us minus 12x squared, and 2x times plus 1 will give us plus 2x. This will give us 3x minus 1. Simplifying within this bracket, 9x squared and minus 12x squared will give us minus 3x squared. But first we write the x cubed in front, 18x cubed minus 3x squared plus 2x plus 9. So this is the final answer for the first question. Now let's look at the second question. Part B, we are asked to differentiate this. This can be first written as x squared followed by the bracket 1 minus 2x squared to the power of half. When you have a square root, it means the power outside the bracket is half. So let's write this down. X squared 1 minus 2x squared to the power of half. So applying the formula again, we'll have, let's leave this alone first, x squared. Differentiating this, bring down the half to the front of the bracket, we'll get, copy down the bracket as it is, subtract 1 from the power. Now differentiate within this bracket. The 1 will disappear. The 2 bring down will give us negative 4x. Now plus this bracket, leave it alone. Now differentiate this expression, there is the u here. We are differentiating du dx. In other words, differentiating the x squared will give us 2x. Now let's simplify this answer here. First, the 2 can cancel with the 4. To give you 2. So we have 2x multiplied by the x squared. That will give us negative 2x cubed. And this is over this bracket. We can bring this to the denominator. Because the power is negative half, when you bring down to the denominator, it becomes positive half. And then the plus sign here. Now this can be written as 2x followed by the bracket here, 1 minus 2x squared to the power of half. Now when we multiply this bracket to the top and to the bottom here of this fraction, what we get will be, now the reason why we do this is that so that we can combine the two fractions into one. So we multiply this factor here to the top and to the bottom of this fraction. Now the denominator is the same, they can be combined into one. So in the denominator we have this 1 minus 2x squared to the power of half. On this side here we have minus 2x cubed. And here we have plus 2x and this bracket. To the power of 1. When you multiply these two brackets, you add the powers. Half and half will give you 1. Now let's further simplify the answer. You will get minus 2x cubed plus multiplying this 2x into the bracket 2x minus 4x cubed. So when you have minus 2x cubed and minus 4x cubed, what we get is minus 6x cubed. So let's put this in front. 2x minus 6x cubed, whole thing divided by the square root of this bracket. Or you can leave it in this form, this bracket to the power of half. So that is the final answer for this second question.